Hey everybody, Mr. Enyart here. Welcome to Mr. Enyart's Mathematical Compositions. This is grade 6, module 5, lesson 9, and it's actually just part 1. I bounce around a little bit in here, but I don't have enough time to get through the examples, the teaching, and the whole problem set. So there will be a part 2 that has the last few questions of the problem set. All right, let's do this. Hey everybody, this is grade 6, module 5, lesson 9, and we're going to be looking at perimeter and area of polygons, two-dimensional figures, on the coordinate plane. And first we need to understand what perimeter and area are so we don't get them confused. So this would be a great time to pause the video and take notes. And then as I continue to comment on these, add those to your notes. So go ahead and do that now and write this stuff down. All right, so perimeter, right? You see the word rim in there. So if we were to just underline R-I-M, rim, and if you think of a rim or a basketball rim, you think of the outside of an object, the surrounding space. So I've written a lot into my definition and trying to make it as 6th grade kid-friendly as possible, but it's units of length. So it's just an amount of length, all right, an amount of distance that make up the outside edges or sides added up of an object. So it's the surrounding, it's the rim, it's the sides added up. That is perimeter. So when we look down at this figure for number 1, the perimeter is if we were to add up this side and 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 this side, how long would that be? If this was fence around a yard, how much fence is that? What is the edges added up, the sides added up, total length all the way around? Okay, now area, however, is the square units that fill up a two-dimensional object or a polygon on the inside, right? So it's all these little things inside, 4, 8, 12, 16, 20, continue on and on and on. And there are formulas we can use, right? There's a couple formulas for perimeter, but only of specific shapes. If they're regular shapes and it's a rectangle or a square, there are formulas where we can add things, and since we're adding repeatedly, you can multiply. But for area, we've learned these ones so far. So area equals length times width is what works for any rectangle, right? Length times width, because rectangles have parallel sides, perpendicular sides, right angles. Length times width works because it makes an array. Now, side squared would give you the area of a square. So because both sides are the same length, if let's say they were 6, we could do 6 times 6, which is just 6 squared. So this is the formula for area of a square. Area equals base times height. This is the formula for the area of a parallelogram, right? We don't use the diagonals. We need 90-degree angles so that we can make square units. And so area equals base times height means we use the base and we find how high it is from the bottom to the top, or from the base to the opposite side of the parallelogram, and then we can multiply those two and we'll get the area of that parallelogram. And then base times height divided by 2 is the area of a triangle. So let's work on a couple problems and see how we can find perimeter and area. So just a reminder, pause the video as we go and read the questions. I'm going to be jumping right in for the sake of time, but that's the beauty of video learning, is you can pause it and move at your own pace. So we need to determine the perimeter and area of the figure down below. And so to find area, we're just going to calculate all of the sides. We have a 4-unit length side there. So I've went ahead and filled in all the rest of the sides just by counting them, okay? And then you add them all together and you get a total length of 42 units. It didn't tell us feet or inches or centimeters. So all of those are just different units. When you don't know, you use the letter U or the word units. And since it's just a length, we don't need that whole squared thing, right? Because we're not adding squares. We're just adding the length of this line and this line. And if we were to take all these lines and flatten them out, we would literally just be measuring the length of a line, which is just units. It might be feet, it might be inches, it might be centimeters, but in this case, units. So let's go through the area. For the area, you're going to want to split the figure up, usually, if you're going to use formulas, into 2 different rectangles. So you can do it there, or you could have done it there. I prefer the horizontal one. And so what I see is a 7x4 rectangle on top. Okay, and then I see a 6x8 rectangle on the bottom. And so 7 times 4 is 28. 6 times 8 is 48. And when you add those together, you're going to get an area of 76 units squared. Now, we're not squaring 76. 76 is the total number. What we did, units times units. And so we're going to call them units squared. And they literally are making 1 by 1 square units inside. This right here is 1 unit by 1 unit. And there's 48 of those in there, right? And then there's 28 of them up here. And again, putting those together gives you 76 total of the square units. Okay, so you try to find the area and perimeter of this figure. All right, so to find perimeter, we're just going to add up all the sides. So we're going under the assumption that this is a regular hexagon. Hexagon has 6 sides. That is the name of this pentagon. And we're going to assume that they are all 4s because it looks regular. It didn't tell us that, but we're assuming it is regular. So 4 on top, 4 on bottom, which would mean these diagonals are going to be 4 units as well, even though they look like they're only 3. But again, at the angle, we're not sure. So we're going with 4s all the way around, and that means if our perimeter formula could be side plus side plus side however many times, right, it would just be adding 4 plus 4 plus 4 plus 4 plus 4 plus 4. But do you see a multiplicative or a multiplication relationship here? Yeah, there are 6 groups of 4. So we can do 6 sides times the length of 4 units per side, and we'll get the same answer. So you can still use multiplication in perimeter because you're just combining lengths over and over again, and if they're the same length, then that's multiplication. And that's fine. You can add them all up, but just don't get confused. We're not multiplying a length and a width here. We're just multiplying equal lengths over and over again. And so that's going to give us 24 units. Right now for perimeter, that's all we have to do. But for area, we're going to have to divide this up. So I'm going to cut it here and here to make 2 triangles and a rectangle. So I need to write in one more length, and that would be the base of the triangles and the height of the, or the width of the rectangle. And it is 5. So we have 4 by 5, which is 20 right here. And then we also need to get the height of the triangle from the base 90 degrees to the tip. And they're both the same, and they look to be 2. So now we're looking at a 5 by 2 triangle base to height. And remember, area of a triangle is base times height divided by 2. So 2 times 5 is 10, and 10 over 2 is 5. And we have 2 of those, right? Plus the 20. So we've got the 20 rectangle, the 2 5s, which I'm just going to write as 10, gives us a total area of 30 squared units. Did you figure that out? Go ahead and try these real quick, just area, not perimeter, and see how you do. Pause the video and I'll go over it in about 3 seconds. So maybe you set the first one up like this. You cut it into a group of 3 smaller rectangles, 2 of them happen to be squares, and 4 congruent triangles that have a base of 3 and a height of 3, which of course is going to be 4.5 for these when you do base times height divided by 2, right? So you've got 4 of the 4.5s, and these would be units squared. Oops. And then you have a 9 by 4, which is 36 units squared, and then you have the 2 3 by 3s, which are 9. All right, so you can add all those together, and you would get the area. So figure that out. Right, so you should have got 72 units squared because you got the 36. 18 is 4.5 4 times, 9 and 9. And then the 9 and 9 here is the other 18. So that's where my numbers come from. Pause it if you need to look back and figure out how. But you add them together, you get 72. But there is another option. So I just drew something. How can I use this to help me find the area of this? So hopefully you were saying, well, find the area of the rectangle because it encompasses this figure right along its edges on the bottom, the top, the left, and the right. But then what would I do? Now, what about these spaces? What would I do with these spaces if I knew the area of the whole rectangle? Because this figure does not make up the whole rectangle. I find the area of these 4 congruent triangles and I subtract it from the total of the rectangle, and I should be left with that. So go ahead and try that now. Find the area of the rectangle, find the area of these triangles, and subtract them, and see if you still get 72. All right, so did you get this? Did you get a 9 by 10 rectangle, which is 90 units squared, and then each of these are 4.5, so they're the exact same as this, and so that would be 18. These four added together is 18, so you subtract 90 and 18, what'd you get? Bada bing, bada boom, 72, right? Because you'd regroup, make that a 10. So they're both going to work. So this will be the last problem of this video, and then I'll do the problem set on a different video. But go ahead and find the perimeter and area of this figure. Pause the video, go for it, write your answers down, then check back with mine in a few seconds. Well, when you're done. So hopefully you got something like this. Since the formula for perimeter is just side plus side plus side plus side, so on and so forth, I just found the length of all the sides, and I added them together to get 62 units. For the area, I just cut it in half right there. Well, not in half, but I drew a horizontal line to give two different rectangles. One of them was 6 by 15, which is 90. The other is 4 by 10, which is 40. And when you add those together, you get 130 units squared. Now, yes, you could have done this as well. Now, me personally, I am a man of efficiency. Why do something that takes 3 steps when you can do something that takes 2 steps? Because if you do this, you have to find the area of the entire figure. Then you have to subtract this and this instead of just draw one line and add together these two after multiplying the length and width of those two rectangles. For me, this is a step quicker, and it's going to get me the same result, so I'm going to do the one I do in the red, not the one I do in the green. Okay, scratch what I said about making another video. I think in one more minute I can give you the answers for the problem set, but first, hold yourself accountable. Pause the video and do all of the problems on the problem set, perimeter and area, or just area if it asks, like this first one. Make sure you read the directions carefully, because a lot of the ones that have slanted lines that you can't really find the distance, and it's obviously not a regular figure, which means all the sides are the same, then you're just finding the area. But some are perimeter and area. All right? Pause it, do it. I'll put all the answers on and finish this up in 1 minute. Okay, number 1, I found the easiest thing to do was to make the outlining rectangle and subtract the space that is not part of the original figure. So the outlying rectangle was a 13 by 12, which is 156 units squared. Each triangle, base times height divided by 2. So this was 40 divided by 2, which is 20. 16 divided by 2, which is 8. 25 divided by 2, which is 12.5. And 35 divided by 2, which is 17.5. When you add those together, you get 58. And when you subtract, you get 98 units squared as my total area. For this problem, perimeter and area, perimeter is all the sides added, so I counted the sides, added them up, and got 58 units. For my area, I broke it here and here instead of making the whole rectangle and subtracting out the space I'd have to figure out. And so we have 4 plus 65 plus 45 shown down here, and I got 114 units squared. For the area of this, our formula or our expression could be the area of this triangle, which is half times 5 times 5, the area of this rectangle, which is 1 times 5, and the area of this rectangle, which is 13 by 7. Then you simplify it by solving each one. 12.5 plus 5 plus 91, and you get 108.5 units squared. Feel free to pause and look back over this one to make sure you know how to write that expression and what each number and parenthesis symbol represents. So if you just said that it doubles the area for number 4, you are way wrong. Don't be mad at yourself. It's cool. Lots of people would think that. So let's look at why. If you look up here, I rewrote the formula with each of these sides doubled, right? Because if the box is doubled, then 1 is 2. 2 is 4, 4 is 6, so on and so forth. So 5 would be 10, 1 would be 2, 13 would be 26, and 7 would be 14. So when you go back and you solve it, you end up with 434, which is way more than double 108.5. And of course, that is still units squared. And unfortunately, I am going to have to do question 5 through the end, which I think there's only 7 questions, on a separate video for time. So go ahead and click out of this and tune into the video that is Grade 6, Module 5, Lesson 9, Part 2, questions 5 through 7.